Welcome back to part 2 of the comprehensive inspection, maintenance, and repair of a viewer's 99 C5 Corvette with less than 30,000 miles on it. In part 1, we talked about the fact that the new owner just recently bought this car for $12,000. It's only been driven 3,000 miles in the past 15 years, and the air conditioning and anti-lock brakes do not currently work. The owner has asked me to investigate these issues further, and so in part 1 we diagnosed the problem with the anti-lock brakes is being caused by a bad electronic brake control module, which he knew was a distinct possibility, but he was hoping for something much less sinister. So let's pick up right where we left off. I've got a lot more work to do, so let's dig into why the battery keeps dying so quickly. Place your bets in the comments below. Is it because of excessive parasitic draw, a bad 1-year-old battery that's been seriously abused, or the alternator is no longer charging? For the parasitic draw test, I left the positive battery connected. The negative battery cable is disconnected, and I had to rig up a vice grip with that bolt to get a solid connection for something to grab onto with my test meter. So I initially start with the black lead on there. In case it's more than 10 amps, it would blow the meter's fuse. And so it starts with that when you first connect it. Then as the modules start falling asleep, you can disconnect this one. Now everything is flowing through the meter itself. And right now we have 250 milliamps. I'm shooting for somewhere around 75 milliamps or less. Let's see if more modules go to sleep. It's been about 15 minutes. We're still at 250 milliamps. Looking at this underhood fuse center, I suspected it might have something to do with the bad EBCM. As you can see over here, fuse 53 and 52 are for the ABS system. So take a look at this. 250 millivolts. Again, we're hoping for less than 50 milliamps. And watch what happens when I pull fuse 53. We're at 10 milliamps. Now I'm going to go ahead and plug this back in. Now we're at 650 milliamps, 680 milliamps. And it's been about 10 minutes. This time it only wants to drop down to 0.7 amps or 700 milliamps. That's really bad. Once again, I'll pop fuse 53 out of here for the ABS. And hopefully this time it'll go to sleep. 350, there we go. That's about 80 milliamps. So, being as how that was fuse 53, again, that's this one right here, 53. 53 is ABS. And being as how we have problems with the ABS, I think that further validates there's something going on inside the EBCM. So now the question is, by leaving this fuse out, is that going to have any effect? Is it going to take down the network or anything? Cause any other drivability issues? We're going to try it out. On a C5, the normal battery voltage with the engine running will vary between about 13.5 and 14.5 as the computer varies the charging. This can easily be tested with an inexpensive multimeter that every car guy should have. Alright, this battery sat all night and charged, and now it's stabilized for about 15 minutes. Let's see what the voltage is. About 13.2. That's actually really good. Now let's go ahead and hook up the 140 amp old school load tester. That's a pretty good amount of resistance. Okay, we've got the load tester hooked up, 140 amp load. Let's see how it goes. Not too bad, actually. I actually thought the battery is shot, but it's just a little bit weak. That's not bad. For the fuel injector balance test, the scan tool applies the same starting fuel pressure to each injector. Then the fuel pump is turned off and the scan tool proceeds to pulse the injector a certain number of times. Then you record the ending pressure number and move on to testing the next injector the exact same way. If an injector is clogged, its pressure would not drop as much as the other injectors. All 8 of these look to be very close in pressure drop, which is great. LS1 throttle bodies build up carbon over the years, and it can cause rough idle if it gets too thick in the area where the throttle blade closes. To clean it, we simply remove the air intake tubing to the throttle body, then with a trusted assistant, Mila, don't cut my fingers off. And with the ignition on, I have them hold the throttle body as I clean the blade and the inside of the bore. This one wasn't terribly dirty. Okay, slowly push it all the way down and all the way up. Now it's time to go for a test drive while scanning with HP tuners to objectively see how the engine is running. At idle, I'm mainly just glancing to make sure the oxygen sensors are fluctuating around 450 millivolts. I like to see the mass airflow sensor number moving, and I like the long-term fuel trims to be plus or minus 10 and equal on both sides. Here's the scan from our test drive. Just a few things to note. Number one down here, it was about a 20-minute test drive. And the first thing I'm really looking at is this line up here. This is a table essentially of the long-term and the short-term fuel trims combined, plotted against the frequency of the mass airflow sensor, which increases with RPM. And by being red, it means it's adding some fuel. And on an untuned vehicle, I want these to be plus or minus 10. Gets up to about adding 8% fuel, so we're okay. At wide open throttle, the narrowband oxygen sensors in the fuel trims are not accurate, so it would be up here, and I filtered that out. So what I look at are the oxygen sensor values here. And anything above about 860, 870 with a narrowband, it generally is in the ballpark for what it should be. Only way to be 100% accurate would be to use a wideband oxygen sensor, but this is definitely not lean. And then lastly, right here, you can see that I hit wide open throttle, close to 100%, and we did get about 8 degrees of knock. The learn was 0.99, so basically this thing has probably not seen wide open throttle in a long, long time. It will learn if there's knock, and it'll reduce the timing on its own. You can see here it reduced it from 28 down to about 18 degrees before top dead center, because of the knock that was experienced. So this will adjust itself over time. If the owner of this vehicle wants to get this thing tuned down the road, like if we do an aftermarket air intake system or something like that, it would make sense to tune this and clean this up as well. Because what happens is the computer tends to take out, it overshoots. It took out 8.5 degrees, dropped this all the way down to 18 degrees of timing. If he fills up with, say, 91 octane, and we're still getting 8.5 degrees of knock here, in the tune, I would change this, and most likely it's not going to overshoot anymore, and maybe we would end up at 22 degrees, which picks up a little bit of power because it doesn't have to take such drastic measures pulling out 8 degrees of timing. Other than that, I really didn't see anything of concern, and overall for a car that has sat for a long time, in conjunction with that fuel injector balance test that we did, I would say it's running pretty decent. One last thing from the test drive, I always check the oil pressure with the engine fully warmed up. That means both the oil and the coolant are at about 200 degrees Fahrenheit. And here we have oil pressure of 39 pounds per square inch at 1150 RPMs and 29 pounds per square inch at 650 RPMs, both of which are perfect. Next, I knocked out the fluid changes, starting with the coolant, and I always use DexCool. And always make sure that the fluid you drained out was DexCool as well. If you need a step-by-step video on how I go about changing coolant in the C5, check out the video in your upper right-hand corner. The engine oil and filter were next, which most of you know how to do, followed by the transmission fluid and filter, and that's a bit trickier, so here's a video on how to do that as well. For the differential, we're just going to check it and top it off if necessary. There is a tag on the side of the housing, by the way, that also shows the 315 gear ratio. There is no dipstick, so I made my own, and this one is about 1 ounce or so low, so we'll top it off. The brake system work starts by inspecting all 4 rotors, calipers, pads, and hoses. Then the fluid change was started by evacuating the nasty and likely 25-year-old fluid out of the reservoir, and then manually bleeding all 4 wheels to get the new fluid into all of the calipers, in addition to just the master cylinder. It's kind of satisfying. Power steering fluid is neglected and cheap and easy to do a partial change of. The reservoir is simply emptied and new fluid is poured in. This replaces about 40% of the fluid, so I recommend doing this again one more time next spring, which will end up replacing most of it. You have to look at the harmonic balancer on every single C5 and C6 because they are one of the most common parts to fail on these cars. This one has a slight wobble to it and the belts are a tiny bit noisy, probably due to the rust on the balancer that has accumulated from lack of driving. This balancer looks to be original and I do not see any signs of it failing, but I mark it well anyway with white paint so the owner and or I can keep an eye on it, looking for any separation. The belts are starting to show their age with some minor cracking, and I'm going to suggest to the owner that they be replaced next spring. Battery acid corrosion on the computer. The good news is there is none. Here's what this car's computer and main wiring harness look like, and it's almost like new. And here's what they look like on another C5, where a leak-free, and I am being sarcastic, lead-acid battery leaked for quite some time, dripping acid all over this area. This is preventable, folks, by using AGM batteries. There's a video on it in your upper right-hand corner. While we're underneath the area by the battery, we're also going to clean the rain udder, and this one is empty. By contrast, from a different C5 Corvette, here is the exact same rain udder. This time I removed it from above, and as you can see, it's almost completely plugged with dead plant material, which means this car has likely spent a lot of time sitting outside underneath trees. It's a good reminder that not every single C5 is pampered and stored inside. Underneath the C5, the only thing that I found that really needs to be replaced in the near future are all 4 of these plastic anti-roll bar end links. In the later year C5s, GM switched to metal end links, and the GM engineers didn't do that because they were bored. The plastic end links are known for stretching and sometimes they even break. All 4 of these are still in one piece, but the rubber boots that seal the little ball joint are all shot, which means dirt and grime will get in there and they'll be wore out soon. The final item I'm including in this video is the air conditioning. As mentioned at the beginning of part 1, it doesn't work. The new owner was aware of this when he purchased the car and he made sure that the price reflected that accordingly. Now, I am not an air conditioning expert, but there are a couple of simple checks I can do to see if the problem is something that's kind of simple or if it's something more serious. The first thing I'm going to check is the air conditioning system's low side static pressure, and I do this by connecting a loaded air conditioning recharge kit with a gauge and a hose to the low side port on the car's AC system. Just before I snap this onto the air conditioning's low side port, I give this just a tiny shot of refrigerant, which purges the air out of this hose, and then I quickly snap this onto the low side port, and that minimizes the chance that I introduce any outside air into the car's air conditioning system. Now that the hose and the gauge are connected to the car's air conditioning low side port, I see that we only have 3 pounds of pressure inside the system, which means it's almost completely empty, as it should be around 70 pounds per square inch in a shop that's about 70 degrees Fahrenheit. All C5 and C6 Corvette air conditioning systems contain refrigerant and a little bit of oil. When the refrigerant is leaking out of a hole somewhere in the system, it carries along with it a little bit of oil as well, leaving an oil residue, and that almost always attracts dust and dirt, kind of leading to a grime buildup. So I investigated and took a look at everything I can see from up above, and I don't see any evidence of a grime buildup. So I went underneath and took a look, and the only evidence of grime buildup that I see is on the air conditioning body of the compressor itself, which unfortunately is not terribly unusual, and so I think they're probably going to find that the air conditioning compressor is bad. This C5's air conditioning system will need to be repaired by a shop that's certified in Minnesota to do air conditioning work. I suspect the first thing they'll do is double check my conclusion that the system's empty. Then they'll charge it with nitrogen to a pressure of above 100 pounds per square inch, and they'll listen for hissing noises and signs of where that nitrogen is leaking out. Once they hear where it's coming out, they'll spray a soap and water solution on that area and see if they can locate the little signs of bubbles forming, which proves where the leak is. After that, they will fix the leak, and then they will apply a vacuum to the system to remove all of the nitrogen and the air from the system, and they'll recharge it with a little bit of oil and the proper refrigerant. That's going to do it for this video, guys. I hope you found it to be both useful and interesting. If you did, please tap that thumbs up below so YouTube knows to share this with the Corvette community. Consider subscribing, and most of all, thanks for watching.